Today's Daily Dose of Math is about the rectangle. We're going to start by finding out what a rectangle is. The definition of a rectangle is a quadrilateral that has two pairs of opposite congruent sides and at least one internal 90-degree angle. In this rectangle, we show that the internal angles are all 90 degrees by putting these symbols in the corners that look like a little square. And we show that the opposite sides are congruent with these symbols that are lines. The short sides each have one little line, and that tells us that they are the same length as each other. The two longer sides have two little lines each. This shows us that they're the same length as each other and allows us to realize they're not the same length as the two short sides. Now, the definition does not say that the rectangle has to have four internal 90-degree angles, but it does. The reason the definition does not say it is that once you have one internal 90-degree angle, if it's a quadrilateral that has two pairs of opposite congruent sides, that forces the other three internal angles to also be 90 degrees. So it's only necessary to specify one internal 90-degree angle in the definition. You might ask yourself, is a square also a rectangle? And the answer is yes, because a square has at least one internal 90-degree angle. And although a square has four congruent sides, we can still say that it has two pairs of opposite congruent sides. Is a rectangle also a rhombus? And is a rhombus also a rectangle? We have a yellow rhombus here. We can see that it's a rhombus because we have these little lines on the sides, which are indicating that these four sides are all equal in length. Our green rectangle has similar lines on the two short sides. They're equal in length to each other. But the double lines on the long sides are showing us that these two sides are equal to each other, but are not equal in length to the short sides. Let's look at the definitions for both shapes. A rhombus is a quadrilateral that has four congruent sides. Yes, our yellow rhombus is following this rule, but our green rectangle is not. But can it? Is it possible for a rectangle to have four congruent sides? The answer is yes, because a square has four congruent sides, and a square is also a rectangle. This rectangle is not also a rhombus, but it is possible for a rectangle to also be a rhombus. Now, the definition of a rectangle. It's a quadrilateral that has two pairs of opposite congruent sides and at least one internal 90-degree angle. Our green rectangle is following these rules, but our yellow rhombus is not. Although it has four congruent sides, we can still say it has two pairs of opposite congruent sides, so the rhombus is following that part of the rectangle's rule. But a rectangle has to have at least one internal 90-degree angle. This yellow rhombus does not have any internal 90-degree angles, so this yellow rhombus is not also a rectangle. But can a rhombus also be a rectangle? Yes, because a square is a rhombus, and a square does have internal 90-degree angles. So the answer to both questions is not necessarily. A rectangle can be a rhombus but does not have to be, and a rhombus can be a rectangle but does not have to be. Is a rectangle also a parallelogram? And is a parallelogram also a rectangle? Here we have a purple parallelogram, and we can see by these little lines that the two shorter sides are the same length. And the little double lines show us that the two longer sides are also the same length. The same thing is happening in the green rectangle, but we also have these little squares in the corner that show us that all of the internal angles are 90 degrees. Now let's look at the definitions of the two shapes. A parallelogram is a quadrilateral that has two pairs of opposite congruent sides. Well, both of these shapes are following that rule, and in fact, all rectangles follow this rule, so therefore all rectangles are also parallelograms. A rectangle is a quadrilateral that has two pairs of opposite congruent sides and at least one internal 90-degree angle. Well, our green rectangle is obeying this rule, but the purple parallelogram is not. This particular parallelogram is not a rectangle because it lacks the internal 90-degree angle. But can a parallelogram have internal 90-degree angles? Well, yes. We just said that all rectangles are actually also parallelograms. So therefore, those parallelograms that are also rectangles follow the rules of rectangles, and therefore some parallelograms are also rectangles. Is a rectangle also a trapezoid? And is a trapezoid also a rectangle? Here we have a green rectangle. We can see that the two shorter sides are equal in length to each other, and the two longer sides are also equal in length to each other. We see by these little squares in the corners that it has 4 internal 90-degree angles. In orange, I have two trapezoids, an isosceles trapezoid and a right trapezoid. In the isosceles trapezoid, sides AD and BC are equal in length, as shown by the little lines, and there are no internal 90-degree angles. In the right trapezoid, none of the sides are shown as being equal in length, and there are 2 internal 90-degree angles. Furthermore, there's notes here that show that in both trapezoids, side AB is parallel to side CD, and side BC is not parallel to side AD. This information becomes necessary once we look at the definitions of a trapezoid and a rectangle. Let's look at the definition of a trapezoid first. A trapezoid is a quadrilateral with a pair of opposite sides that are parallel, and in which the remaining pair of opposite sides are not parallel. Warning: this is the exclusive definition of a trapezoid, which is the definition that is used in the curriculum within which I teach. But there is also an inclusive definition of a trapezoid, which is used in some school curriculums. Therefore, when you're looking at the information in this video, you have to check the definition in your local curriculum of a trapezoid in order to find out if these facts apply or not. My rectangle does not qualify as a trapezoid by this definition, because while it certainly has a pair of opposite sides that are parallel, the remaining pair of opposite sides will also be parallel. It cannot be a trapezoid. Now let's look at the definition of a rectangle. It is a quadrilateral that has 2 pairs of opposite congruent sides and at least 1 internal 90-degree angle. My isosceles trapezoid cannot be a rectangle because it only has 1 pair of opposite congruent sides, and it does not have any internal 90-degree angles. My right trapezoid also cannot be a rectangle because although it does have at least 1 internal 90-degree angle, it does not have 2 pairs of opposite congruent sides. In fact, it cannot have 2 pairs of opposite congruent sides. Therefore, the answer to both questions will be no. Using the exclusive definition of a trapezoid, a rectangle is not also a trapezoid, and a trapezoid is not also a rectangle. That is today's Daily Dose of Math. Please like, subscribe, and share.